Section 6.2 continued. So far, we have worked several examples where we knew the z-scores and we needed to find areas under the curve. In some instances, however, we might know the probability or the area under the curve, but we need to know the corresponding z-score. Essentially, with this type of situation, we're going to be working backwards. Example 5. Find the z-score that defines the area under the standard normal curve. So again, just like we did before, we're going to start off by drawing a picture, and then I'll show you how to find these values. So for A, we know that 55% of the total area lies to the left of Z. So Z is what we don't know this time, but we do know the area. So I'll start with my picture. There's 0. And 55% of the total area lies to the left. Well, that means my shading is going to be somewhere over here on the left side. But if I'm at 55%, I have to be a little bit past 0 because 0 is 50%. So if I want to smidge past 0, that means I need to be right here. So I'm looking for something, a value that when I go to look up the area, that this area here is 55%. I'm looking for the z-score that gives me that. Well, you're still going to look in your table, and because this z value falls on the positive side, we're going to look on our positive table. But this time, instead of going on the side and across the top to look for a z-score, I'm going to kind of look in the middle and try to get something as close to 0.55 as possible. So I'm looking up here, and you might want to follow along in your book. I know this table's not very clear. If you look on the row for 0.1, this value here is 0.5517, whereas this is 0.5478. So we're not going to get 0.55 exactly, and that's okay. It's understood that tables can't give you that level of accuracy. But I'm going to say that 0.5517 is a little bit closer, so we'll use this value here, which means the z-score that got me there is 0.13. So my z-score that would give me an area of 55% is 0.13. So it's possible that the true value is maybe more like 0.126 or 0.127, something that falls in between that 0.12 and that 0.13. But if it's understood you're using a table, it's perfectly acceptable to choose something that's a little bit off in that second or third decimal place. Okay, let's take a look at B. 8% of the total area lies to the right of Z. So I need a picture to know what's going on. I'm going to the right, so that means I need to be on this side, but this is a pretty small area, so I'm thinking my Z is going to be right there. But I do know that this little area here, I already know that that is 8%. So I'm looking for something in the tail that's pretty small, 0.08. Well, remember, our tables gives us values going to the left, but because the standard normal curve is symmetric, I'm going to look on the negative values and just kind of ignore the negative signs. So if I go to the negative table, and I'm going to try to get as close to 0.08 as I possibly can. And somewhere in here, it looks like, so it looks like somewhere in here, we have 0.0808, which is very close, or 0.0793, which is also very close. So you probably could go with either of these values. They're almost the same distance away from 0.08. Sometimes you can even split the difference and say 1.405, something like that. But if you chose 1.41, that would be okay, or 1.40, that would be okay. I'm going to go ahead with the 1.41. So the z-score here is 1.41. Now, even though I was on my negative table, I have to look at my picture to know that this value should be positive. And then let's take a look at Z. 95% of the total area lies between negative Z and Z. So we have two values this time. Well, we're kind of used to that number, net 95, and that means we're probably out this far, and we have Z and negative Z. And we know that the area in here, we know that that is 95%. But I'm looking for the two Z values that give me that. Now, if you remember your empirical rule, you might already kind of have a clue about this one, but let's go ahead and show you how to do it, just in case you get some other type of values. Well, remember, I know the entire area of the underneath the standard normal curve is 1. So I want to be able to find these tails here. And that means I'm going to do 1 minus 0.95, which is equal to 0.05. Now that's the total area that's not in between. So that means that's this area here and this area here. But because I have the same value on each side, that means these two tails are symmetric. So I'm going to take that 0.05 and divide by 2, which gives me 0.025. So that means each tail is worth 0.025. And I really only have to find one of them to find out what that z-score is. So I'm going to go ahead and look in the negative table, since that one is usually what this picture looks like. So I'm not looking on the sides. This is not a z-score. I'm looking for the area, and I'm going to try to get as close to 0.025 as I possibly can. And it looks like up right there, right on the nose. So that is a value of negative 2.81. So negative z equals negative 2.81 and positive z equals positive 2.81. So that's kind of working backwards. Be very careful that you don't mix up what you're finding, because depending on if you're finding the area versus the z-score, you have to use your table a little bit differently. So here we went searching kind of in the middle, and there's no real shortcut to it. You just kind of have to look for the trend in the numbers. But we went searching for the area that in the middle of the table that matched the area we were talking about, and then we figured out what the z-score was that corresponded to it. Okay, finally we have the z sub alpha notation. And that notation is pretty much doing the same thing what we did in example 5. It's asking for the z-score with an area of alpha to its right. So the thing you have to be careful of here is that z sub alpha is always talking about to the right, whereas what we did above, sometimes we were to the left and sometimes we were to the right. So here it's strictly to the right. So for example 6, I want to find z sub 0.01. So again, I draw a picture. And here's 0. And if I have an area as small as 0.01, I know I have to be in the tail. And I know it has to be on the right side since we're going off to the right. So what I know is that this area is equal to 0.01, and I'm looking for the z-score. That's going to give me that. So again, remember our tables tell us areas to the right, but because the curve is symmetric, I can just look up the negative values. So I'm going to look on my negative chart, and I'm going to try to find something as close to 0.01 as possible. Okay. 0.01. So right here we're looking pretty good. 0.0099, that's pretty close. And 0.0102, that's pretty close. I'd probably go with this one. So that gives me, if I look at where that comes from, that's a z-score of 2.33. So the z-score here I'm looking for is positive 0.233 since I'm on the right side of 0. So that's all the z sub alpha notation is asking for. Just know that it's specifically asking for an area to its right. If we want to look for an area to the left, then we have to explicitly state it as we did in the previous examples.